All right, well, hopefully at this point you've reviewed factoring. You went to the link at the beginning here to review it because it was a concept taught in Algebra 1. The different methods are there as well in your notes you can look back at. That's what I have a copy of here, your notes. So the 3 questions you need to ask yourself when you're approaching every single one of these, just follow through that. So question 1 here, is there a common factor? Look, is there something I can divide both of those numbers by? Yes, we can divide them both by 5. So we factor out that common factor of 5 and then divide each of these terms by 5 and put that resulting here. So 5x squared divided by 5 is x squared. 80 divided by 5 is 16, I believe. Yes, 16. Okay, so then question 2 is there a difference of squares? So that is this first term a squared term and is the second term a square number? And yes, they actually both happen to be. Now, if this was a plus sign, no, because it's a difference of squares. Difference means minus. So yes, it is a difference of squares, so we can write it as 5x plus 4 and x minus 4. Because if you go back to your review of factorization method, it talks about how you can review difference of squares. So that factors to that. If I multiplied it out, everything out, I get 5x squared minus 8. Okay, question 2. Same thing, ask ourselves the first question, is there a common factor? 4, 12, and 9? No, there is not. So then, second question, is there a difference of squares? Again, no. We have 3 terms, so there's no way it can be a difference of squares. So third question, is there a perfect square trinomial? Okay, so that means, do we have a squared plus or minus 2ab plus b squared? This just means 2ab could be positive or it could be negative. It could still be a perfect square no matter what. So we look, okay, a is 4x squared, so it could be 2x because 2x squared is 4x squared. 4 times, so basically we get a is 2 because it could be 2x squared plus 12x plus 3 squared because 9 is a square number as well. So 2 times 3 is 6, 2 times 6 is 12. So yes, this is a perfect square. So our perfect square is going to be 2x plus 3 squared. Now the only time it would be minus 3 is if this was a minus 12. Okay, and then question 3, we start back at the beginning. Ask ourselves, is there a common factor? 3, 12, and 63. Yes, the common factor is 3. Factor that out. So we have x squared plus 4x minus 21. And then, is there a difference of squares? No. Is there a perfect square trinomial? With this one, no. Yes, this is a perfect square. 1x squared is still x squared. But there's nothing I can multiply by itself to get a 21, let alone a negative 21. So no, this is not a perfect square. So we have to say, all right, are there factors of c that add to b here? Well, my factors of c, okay, again, 21, my factors are 1 and 21, 3 and 7, and that's it. But because it's negative, it could be negative 1 and positive 21, or negative 21 and positive 1. Or it could be negative 3 and positive 7, or negative 7 and positive 3. Which one of these adds to positive 4? This one. So this factors to 3, x minus 3, x plus 7. Now some of you might be saying, well, on the example problem for number 3, you have it 3 parentheses x plus 7 parentheses x minus 3. It doesn't matter the order here. Referring back to commutative property of multiplication, order doesn't matter when you're multiplying. Okay, and then problem 4 that you did was 4x squared plus 18x minus 10. So again, here, we ask ourselves the same question. Is there a common factor? Between 4, 18, and 10, yes there is, it's 2. So we factor out the 2 and we're left with 2x squared plus 9x minus 5. Then we ask ourselves, is there a difference of squares? No, there is not, because there's 3 terms, not 2. Is there a perfect square trinomial? No, 2x squared can't be a square number, and neither is negative 5, can't be a square number. So we move on to question 4. Is there an expression in the form of x squared plus bx plus c? No, there is not. So we move on to question 5. Are there factors of a and c that add up to b? So are there factors of 2 times negative 5, which is negative 10, that would add up to positive 9? And yes, 10 times negative 1 gives us positive 9. So we factor by, if you look back at that method, this is called the grouping method. We factor by grouping. So it's 2x squared plus 10x minus 1x minus 5. And the factor by grouping, we group the first 2 together, and if you look, basically it's just greatest common factor of those 2 terms we factor out. They each have an x, and they're both divisible by 2, so I can factor out a 2x. So I would have x plus 5 there, and then whenever you have a minus sign here, you always have to factor out a negative. And then look and say, okay, so what's the greatest common factor between 1 and 5? It's 1. So we factor out the negative 1, and then we'd be left with x plus 5. Okay, now you should notice that here the x plus 5 is the same. So we actually factor that out of these 2 terms. So we factor the x plus 5 out, and then we would be left with only 2x minus 1. So it's 2x minus 1 is our other factor. So 4x squared plus 18x minus 10 factors to this expression. 2 times x plus 5 times 2x minus 1. Again, in your notes you see that I have it other way. Again, commutative property, it doesn't matter.